Okay, this lesson is about growth and decay, and we just did a paper on money where we had some money that was growing, and then we also had the value of a car that was decaying. And this is similar to the formula that we used. The formula we used was y equals a times b to the x. And a, in this case, is the same as this big A, and b is the same as what's inside the parentheses, and the x and the t are the same. And the A is the original amount, the amount that we start with, just like this little a is. The R is the percent rate of increase or decrease that they give you. And then if it's increasing, you have to add that to 1, just like we did with money. Or if it's decreasing, we have to subtract it from 1. And T is the time in years. Okay, so let's look at the first one. It says, right now the population of our town is around 25,000. However, the number of citizens is projected to increase about 8% every year. What will the population be in 4 years? So what is the starting amount? 25,000. And so we can put that also where 0 is. And that's also our A, and it's our big A of 0. The 0 right here for this A stands for the original amount. Okay, then we have parentheses, and it says that our rate is 8%, and 8% equals 0.08 as a decimal. Now, we don't put 0.08 in here because we take 8% of 25,000 and then add that amount to 25,000. So we have to have 1 plus 0.08, just like this formula up here. Okay, we have plus because the population is increasing. We need this right there. Let's circle that increase. Okay, now we're going to fill out the table. We're going to put in y equals 25,000, parentheses, 1 plus 0.08, close your parentheses, to the x power. We don't have a t, so we use an x, and we could have gone ahead and added this together and gotten 1.08, and we could have just used 1.08. We'll go to the table, find 0, make sure it's 25,000 at 0, and then we'll copy down the rest of the table. Okay, so at the end of 4 years, I'm going to move that so you can see it. At the end of 4 years, we have 34,012 people instead of 25,000. We started out at 25,000, now we're up to 45,012. Okay, that's an example of growth using this formula up here. Now we're going to do an example of decay. Mr. McDonald bought a farm tractor for $60,000. For tax purposes, its value is expected to depreciate. That means it's decreasing at a rate of 18% annually. What will the tractor's value be in 4 years? So the starting amount is $60,000. We're going to put that where 0 is. Okay, then what goes in parentheses is we have this rate of 18%. So 18% as a decimal is 0.18. We move the decimal 2 places to the left. But we don't put 0.18 in here because we're going to take 18% of 60,000, and then because it's depreciating, we'll subtract it from the 60,000. So we're going to have 1 minus 0.18. And we can actually work that out. 1 minus 0.18 is 0.82. So this is really 0.82. And when you put in your calculator, you can put either one, 60,000 parentheses 1 minus 0.18 to the x power, or you could instead just put 0.82. All right, if we take 18% away from something, that means we have 82% left. So that's why this is 0.82. Then we're going to go to the table and write down the numbers from the table. Okay. So these are, after 1 year, the tractor was worth $49,200. After 4 years, the tractor is worth $27,127. Okay, now I want you to do 3 and 4, just like 1 and 2. On 4, all you have to do is write the equation, and then I will check it. You can pause it if you need to. I'm going to go on and you work this out and pause it and then start it again, and so you can check and see if you're right. Okay, on here, a manufacturing plant sends 50,000 cubic feet of CO2, so we would have 50,000. And you want to cut the emissions, so that would be a decrease by 12%, and 12% equals 0.12. So to what level will the carbon emissions drop in 12 years? We're not going to put 0.12 in here. If we're dropping or decreasing, we're going to put 1 minus 0.12. Oops, 1 minus 0.12. We don't put 1 minus 1.12. We only want to do that one time. So 44,000, 38,720, 34,074, 29,985. So at the end of the 4 years, the carbon level will drop to 29,985. Okay, number 4. For her college fund, Jenny's parents invested $5,000 4 years ago. The account has now reached $6,312. What is the approximate annual return rate on the investment? Now they're asking for the rate or the percent. First, we have to find the equation, and we know it starts at 5,000. And then we can find the ratio, and the ratio will be what goes in here. So to find the ratio, you divide what happens at t equals 1 divided by what happens at t equals 0. So 5,300 minus 5,000, divided by, is 1.06. So that's what goes in here. Okay, now that is not the interest, though. Just like the interest over here was 12%, and this was 1 minus 0.12, this is like 1 plus 0.06, so the interest is 6%. 0.06, move the decimal over to 6%. Okay, we turn the page. Growth and decay, more growth and decay. We have the same formula that we had before, but without the minus. We're just doing increasing exponentials right now. And we have this other different formula. Okay, again, this general formula can be used to describe quantities that increase at a certain percentage rate each year. In finance, this increase is called interest. However, when banks handle investments or loans, they don't simply apply interest once a year. Instead, they give you a little interest throughout the year. When a portion of an investment's interest is given at intervals throughout the year, this different formula must be used, this one right here, where n equals the number of times interest is given in a year. Okay, so this equation that we were using, that's when they give you interest at the end of every year. You put money in the bank, they pay you a little bit of money for keeping it in their bank, and they give it to you at the end of every year. This formula is used when they give it to you like during the year, not just at the end of the year. So we're going to see what that means. They can give you interest annually, which is once a year. Go ahead and write this down because you're going to need to know these words. Okay, they give you interest Semi-annually, that's twice a year. Give it to you quarterly, 4 times a year, monthly, 12 times a year, weekly, 52 times a year, and daily, 365 times a year. Okay, so this formula is a little different. It's almost the same, but we have one extra thing in here, the N, okay? And the N tells us the number of times interest is given in a year. So like if it was semi-annually, N would equal 2. And instead of just having 1 plus R to the T, we're going to have 1 plus R divided by how many times it's given per year. And then we're also going to have it to the, instead of T power, you multiply how many times it's given per year times the years. Okay, so they did the first one for you where it's annually, once a year, and that's that first equation, the one we've been using. So we are investing $6,000 at 4% annual interest rate for 5 years. Okay, so they changed the decimal 4% to 0.04, and since it's growing or increasing, we'll add 1 to the T power, and at the end of 5 years, we get approximately $7,300. Okay, now we're going to compare that to quarterly and monthly. Quarterly is 4 times a year, so N will equal 4. And we start with the $6,000 that we're investing, and then we do 1 plus the rate, which is 0.04 or 4%. Okay, divided by the N, which is 4, and then to the 4 times T power. Okay, then the tricky part is putting this in your calculator correctly. We're going to add some parentheses around the fraction. Okay, so we're going to have 2 sets of parentheses here and another set around the 4T. So 6,000 parentheses, 1 plus, open another parenthesis, 0.04 divided by 4, and close that parenthesis around the fraction, and then we need to close it again to close this one right here. And then rooftop, open parenthesis, 4T. If you don't put, instead of 2, we'll put X. And if you don't put parentheses around the 4X, it will not be correct. And then we'll go to the table. We should have 0, 6,000, and we do. And then we'll write the rest of it down. Okay, so then let's look at the end of 5 years. At the end of 5 years, we've got a little bit more money than we did when we had interest once a year. This is interest. They're giving you interest 4 times a year, like they're giving it to you at the end of every 3 months. And there's like $21 more. So there's a little bit more interest when you give it to, when you're getting the interest during the year. Let's see what happens if you get it 12 times a year or monthly. This would be 6,000, 1 plus 0.04 divided by 12 to the 12T power. So we're going to change this to divide by 12, close parenthesis, rooftop, parenthesis, 12x. Go to the table. Okay, it's a little bit more money. Okay, let's look at the $7,326 at the end of 5 years. We actually have $26 more dollars and only $5 more from when the interest was given every 4 times a year. And another name for this is called compounded interest, which I think you've probably heard of. That's compounded 4 times a year or compounded 12 times a year. Okay, now what would be in the count 5 after 5 years if a little of the interest is given away every week. So every week would be 52 weeks in a year. So y equals 6,000 times 1 plus 0.04 divided by 52, and 52 times 5. Okay, if we put this in y equals, we don't want to put 5. They're putting 5 in place of the x, so they want to know just the 5th year. But we're going to put an x here, so we can put it in y equals. I'm going to change the 12 to 52 and go to the table. Okay, so at the end of 5 years, to be right here, we've got $7,327.90. Okay, so now we have 27 more dollars than we did. And let's see what happens if we do it daily. 365, y equals 6,000, 0.04 divided by 365 to the 365 times, let's change that to x if we're going to put it in y equals. Now if we were putting it in the home screen, you could leave the 5. But since we're putting in y equals, we have to have the x. 365, parenthesis, to the parenthesis, 365x. Go to the table and look for year 5. So $7,328.30. All right, so the difference between weekly and daily is only about 40 cents. Not a very big difference. Okay, we're going to do 6 and 7 and then stop. Okay, we're going to continue completing the tables. So let's go ahead and fill out this table. Let's look at the equation for a minute. This 0.841 tells you if it's increasing or decreasing. Since it's less than 1, it's a number between 0 and 1, it is decreasing. And we know that the first amount is 500 because that's where it starts. So we'll go to y equals and clear that out and put in 500 parentheses 0.841 to the x power. Go to the table. Now we've got 500, and then here, I'll leave it right here and then I'll write it down. 420.5, 353.64, 297.41, and 250.12. Then we have to answer a couple questions. Okay, this is about a radioactive material. It loses its mass over time because some of the nuclear materials releases radiation. The mass of a certain sample changes according to the equation on the left, this one right here. After approximately how many years does the sample have only half of its original mass? Well, it started out at 500, half of that would be 250, so it took 4 years for it to get to half of its original mass. And this is called the half-life. So the half-life equals 4 years. It's the length of time it takes to get to half of what it was. Has all the substance gone after 2 half-lives? Okay. Well, if 1 half-life is 4 years, then 2 half-lives equals 8 years. So let's look on the table at 8 and see if it's all gone. Of course it's not, because it's only taking half of it. So we're going to say no, it's not all gone. It has 125 grams left. Will it ever reach? Will it ever be all gone? And the answer is no, never, because it's never going to get to 0. It's just going to get closer and closer. You're always taking half of it. So there's parts of it that never go away. Okay, now we have a different radioactive substance that loses half its mass over a 6-year period of time from here to here. Okay, a 1,200 gram sample will decay into a 600 gram sample after 6 years. Determine the approximate rate at which the substance decays per year, and then write the equation for its mass over time in years. We're going to write the equation first. It starts at 1,200. Okay, and then how to find what's in the parentheses, that's the B. We're going to find the ratio between these two. So we'll do 1069.1 divided by 1200. I did too many. 1069.1 divided by 1200 is 0.89. Let's round it to 0.891. So we'll put that here. Okay, and let's write the equation. Y equals 1200 times 0.891 to the t. Okay, now we're looking, they want us to write the rate, and the rate is the percent, and this is not the percent that it decreases. Okay, the rate, since it's decreasing, we have to subtract this. So the rate equals, here, let me rewrite this. The rate equals 1 minus 0.891, and that equals 0.109. If you change that to percent, that would be 10.9%. So that's the rate at which it decays. Okay, with your equation, find y of 12 and y of 18. This is kind of like f of x. Instead of, it's y of x. So 12 is really x. So we're looking to see when x is 12 on the table. So we'll go down to 12. So y of 12 equals, oops, I don't have the right thing in here. Got to put my equation in here. Put 1200, parentheses, 0.891 to the x, and go to the table. There we go, 300.41. Okay, now that makes sense because every 6 years it cuts it in half. And so 6 years from 600 would be 12 years. And so after 12 years, we should have half of 600, which is 300. And then 6 more years would be 18. So we half it again, and it should be 150. Let's check the table. And it is approximately 150. Okay, for what interval of time will the amount of the substance be greater than 400 grams? Okay, we're going to look at this on the next part of growth and decay. This is growth and decay part 1, and I will have a growth and decay part 2.